Watch this. In designing a computer's cache system, the cache block or cache line size is an important parameter. They are saying that whenever we want to design a cache system, there are various things. One is what is the total cache size, and then the next parameter is what is the cache block size. And depending upon what you had decided about the cache block size, your performance is going to depend. So they are saying that this which of the following is correct. So they want to have a smaller block size, and what is the reason, or what is there anything favorable, or is there any parameter which is going to support us to have a smaller block size? That is what they wanted to find. So first one is a smaller block size implies better spatial locality. So spatial locality says this, when you are accessing a block somewhere in the when you are accessing a word somewhere in the block, then the spatial locality says that there are chances that next time you will access a word which is in the close proximity to the accessed word in terms of the space, which means if you are accessing, let us say, word number 10 now, then there are chances that you will access plus or minus 10 or plus or minus 5 or whatever. So whatever it is, they want to say that you are going to access next time something which is closer to this. Now the larger the cache block is, the better the spatial locality. The smaller the cache block, it doesn't actually follow the spatial locality. What if I have a smaller block size, what happens is you will fetch only few words, not more words, and therefore you are not following this rule of spatial locality. So smaller block size doesn't imply spatial locality. Having larger block size implies spatial locality. So this is not right. And next one is a smaller cache block size implies smaller cache tag. Okay, so they are talking about the cache tag, hence lower cache overhead. So what is the relationship between cache size, cache block size, and the tag? Watch it. So in case of direct, let us say direct. In case of direct, physical address is divided like this. One is word number or block offset, and the other is line number, and the other is tag. So if you observe one thing, these two factors indicate the cache size also, which means number of lines into size of each line is going to indicate the cache size also. Therefore, there is even if you decrease the size of the cache, this one will decrease, but this one will increase. Therefore, tag bits will remain constant even if you increase the cache size or decrease the cache size. So in direct mapping, even if you do whatever you do with the cache size, the cache block size, the overall cache size is going to be constant. The overall cache size I am talking about. Therefore, the tag bits are also going to be constant. You can take some examples and check it. And let's see what happens in set associative. In set associative mapping, if you observe it, so the least one, this one indicates the block offset or block size, and this one indicates the set number, right? And now this one indicates the tag. Now let us say I decrease the block size. If I decrease the block size, how can I decrease the block size? Let us say I reduce it by half, which means I am pulling away one bit from here. If I pull away one bit from here, if I decrease the cache block size, then what will increase? The number of blocks will increase, or the number of lines will increase by 2 times. See, if the block size is reduced by 2, then the number of blocks will increase by 2. If the number of blocks have increased by 2, then what happens to number of sets? Number of sets will increase by 2, which means if I decrease one bit from here, this one will take one bit, right? Therefore, in any cache organization, you can observe this: the number of sets into the block size, right? This one will be constant as long as you put this k as constant. In case of k-way associativeness, if you put this k as constant, like it is 4-way associative or 2-way associative or 8-way associative, you can take examples and check it, that the sets into blocks, this is going to remain constant, which means even if you change the block size, the number of tags will not change in set associative also. So by having smaller block size, we will not get the smaller cache size, right? In these two, they are going to be constant. What about associative? In associative mapping, you can observe this. In associative mapping, what happens is the physical address can be divided into two parts. One is block size and other is block offset. So when you divide into two parts like this, okay, then what happens is even if you reduce this, whenever you reduce this block offset, this block number is going to increase. This is block offset and this block number. This block offset block number is also the tag here, right? So if you reduce this part is going to increase. Therefore, having a lesser cache block size will imply higher tag bits. So having a smaller tag block size, having a smaller block size doesn't imply any decrease in the cache tags in any of the memory management, right? Therefore, if anything, it increases or it remains constant, but it is definitely not going to reduce, right? And next thing is, a smaller block size implies a larger cache tag and hence lower cache hit time. Yes, this is right. You see, a smaller block size implies larger tag size. This one is fine. At least, in these two, even though it is wrong, at least in associative, this point holds. It is not completely right, but then at least in associative, it holds right. Now they are saying that when we have larger cache tag, they are saying that lower cache hit time. It is false. When the cache tag size has increased, then the hit latency will increase because the comparator size is going to increase, right? This is false because the reason is this: whenever you increase the cache tag bits, then the comparator size is going to increase, and the comparison is going to take time if the number of bits that have to be compared is larger, right? Therefore, it is not going to lower the cache hit time. In fact, it is going to increase the lower cache hit time. So anyway, the first point doesn't apply for direct or set associative. This applies only for associative mapping, and even then the second point is wrong, which means lowering the cache access cache hit time is wrong. Okay, if anything, it will increase it. Next one is, a smaller cache block incurs a lower cache miss latency. So what is cache miss latency is, whenever a cache block is not present, we are supposed to read that particular block from the main memory. Then the time taken for this is depending on the time taken to read the number of words from main memory. In case if you have to read more bits from main memory, more words from main memory, then it is going to take a lot of time. I think you remember the page fault service time also, right? In page fault service time in paging in memory management, what happened? We have observed that as the size of the page increases, the time taken to read the page from the hard disk into the main memory is going to increase. Therefore, the larger page size, even though it's going to increase the spatial locality concept, but then it is going to increase the page fault time, because we have to read the entire page from the main hard disk and get it into the main memory. Similarly here also, if I have a bigger block and whenever that block is not present in the cache, I have to read the entire block from the main memory into the cache. So the miss penalty time is going to increase, right? Therefore, a smaller block incurs a lower miss penalty. So the smaller the block size is, the faster it will be in case if it is not present in the main memory. I can directly get it into the cache. So this is the answer. So which of the following is right? D is right. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, If you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.